This meeting is being recorded.
In section 5.8, we're going to take a look at what are referred to as conformationally mobile compounds. So that means that they are in a state of changing conformation. So most molecules, depending on things like steric hindrance, can rotate freely around single bonds. So whenever we have a carbon-carbon single bond, for example, we can have different conformations we've seen, and we generate these by drawing Newman projections, or we can show these rather. So we've seen in the past this gauche rotational conformation of butane. So we see the two methyl substituents on our front and our back carbon will be next to each other or adjacent to one another. So what we should realize by looking at these two conformations, if we were to try and put a mirror here and reflect one upon the other, we would think that these are enantiomers, right? Enantiomeric in these two conformations. But that's not the case because this free bond rotation that exists and these conformations aren't permanent, right? They're not stuck in either of these positions for a very long time. So these are called rotamers or rotational conformation isomers, right? They are changing, they're interchangeable through this bond rotation at room temperature. So it has enough energy to do this, and therefore it would be an achiral, not a chiral compound. So we see this with not only butane, but with cyclohexane as well. And even specifically here with this example, we have a cis 1,2 dimethyl cyclohexane. And we see the two chair conformations here. And after ring flip, right, so we have one that flips to the other. Both of these conformations would be chiral and also would be enantiomers through our analysis, right? If we were to draw our mirror here and reflect one upon the other, we would see that they're non-superposable mirror images. But again, these conformations will interconvert between forms, so they do not have this chiral characteristic. They would both be considered achiral. And we would see that due to this interconversion, there's not a chiral determination overall. So another way of looking at this is within the molecule itself, there's an internal plane of symmetry. We would also consider these compounds shown below here another view of that 1,2 dimethyl cyclohexane shown at different angles down here. These have that internal plane of symmetry. So these are two ways of looking at the same thing to make that determination that these would be achiral compounds. So we'll continue our discussion of some of the exceptions to chirality in section 5.9.